Two cars leave from Para, Minnesota and travel in the same direction. One car travels 1 1/3 times as fast as the other. After 3 hours, they are 45 miles apart. What are the rates of the cars? To complete this problem, we are going to make use of the equation rate times time is equal to distance d. We'll compile our information into a table where we have information of the rate, time, and distance for the faster car, and then the rate, time, and distance of the slower car. But we first need to define our variables. We'll let x equal the rate of the faster car, and we'll let y equal the rate of the slower car. We can fill in the column for the rate, r, in our table because we've just defined it. The rate of the faster car, r, is x, and the rate, r, of the slower car is y. The two cars have left in the same direction from the same place, and after 3 hours, they're 45 miles apart. So they've both traveled for 3 hours, and we can fill in the column t in our table for both cars with a 3, where t is in hours. Using the formula r times t equals d, we can fill in column d. For the faster car, r times t, or d, is 3x, and for the slower car, r times t, or d, is 3y. Now we're ready to create a system of equations. The first information that we were given is that one car travels 1 1/3 times as fast as the other. This means that the rate of the faster car, x, is equal to 1 1/3 times the rate of the slower car, y. 1 1/3 we'll write as 4/3, and we have x is equal to 4/3 times y. We're also told that after 3 hours, they're 45 miles apart. Since they left from the same place, traveling in the same direction, we need to find the difference of their distances, and we can set that equal to 45 miles. So the faster car traveled farther, so 3x minus 3y is equal to 45. Since we have one equation solved for x, we'll use substitution. We'll substitute 4/3 y in for x in the second equation. We have 3 times 4/3 y minus 3y equals 45. Simplifying the left side, we have 4y minus 3y equals 45. Combining like terms on the left side, we have y equals 45. Now that we've found y, we can substitute that into our equation, our first equation that is already solved for x. We have x equals 4/3 times 45, which is equal to 60. So we have x equals 60. We can check this solution by substituting 60 for x and 45 for y into both of our original equations and verifying that a true statement results. We can also just look at the problem statement and check. One car travels 1 1/3 times as fast as the other. 60 is 1 1/3 times 45, so that checks out. And after 3 hours, they are 45 miles apart. So after 3 hours, we have 3 times 60 minus 3 times 45. That does equal 45 miles. Therefore, the solution checks, and we know that the rates of the cars are 60 miles per hour for the faster car and 45 miles per hour for the slower car.